Everybody welcome Desmond Bowe.
Thank you. Hi, everyone. My name is Desmond, and this talk is called Upgrades Are Not Scary. We're here at the Big Elixir. Is everyone having fun so far? Yeah, it's cool, right? I mean, as someone who puts on conferences, I know the work that goes into these things, and it's always awesome to see them come off so well. I would make one. Sounds cool. I might call this Beard Conf. A lot of strong beards here today. Even that's James on the right. He's the sound guy. You've probably seen him walking around. Solid beard. My name is Desmond. I'm around the internet as Desmond Monster. You can see me there in uniform. As Brian mentioned, I started a conference in New York called MPEX. I now run it in LA. I also host the Elixir Talk podcast along with Chris Bell, who's a good friend of mine. He's the British person. If you listen to a podcast with a British person, that's us, and that's not me. And I work for a company called Versus Systems out in LA, where I'm the head of engineering. I'm not a principal engineer. We make an SDK for game developers so their players can compete in in-game challenges to win real-world prizes. And I talk about it a lot on the podcast. We have a lot of interesting scaling concerns because video games have tons of concurrent users. So if any of that's interesting to you, talk to me later because it's challenging. But I'm not here to talk about that today. I'm here to talk about hot upgrades. And the goal of this talk is to help you understand what they are, how they work, when they're complicated, things you should be aware of. I'm not going to tell you should use them. It's up to you to make that decision. But there's a lot of fear and uncertainty surrounding them, I think, in the community. We've upgrade, whatever. And here so that whether or not it's not scary, it's simply just, oh, yes, I want this, and oh, no, I don't want this because of X, Y, and Z. We're going to assume some familiarity with Erlang and Elixir concepts such as OTP, releases, gen servers, supervision trees, and the Distillery library. This is actually a talk in two parts. I'm going to deliver the first part now, and then later on at the after party, Paul Walker, who wrote Distillery, will issue all the corrections to my talk. So stay tuned for that. And if all of you watching at home are wondering if it's still worth attending conferences, it is, because you can get the corrections later on. What's an upgrade? I'm not going to call them hot upgrades because they're just upgrades. Upgrades to a live system. An upgrade is a type of release. It contains instructions for altering the running version of your application. It lets you add new modules and functions. Individual process state is optionally migrated. It's not necessary, but it gives you the facilities for doing this. The Erlang VM never shuts down, and the computer never shuts down. Everything happens in place. So why upgrades? Well, maybe you don't want downtime. This is not really true. There might be downtime. We'll look at that a little later. But primarily, it's because you're keeping state in memory. The app is being backed by a database and is acting as a caching layer. We see this a lot in sort of traditional web app setups. Or your app is not backed by a database. It's storing everything in memory and that's it, which sounds heretical to us in 2018, but was the way these systems were originally written to be deployed. So if your state is all in memory, there's only one way to change it. If you turn off your app, you lose your keep serving requests. So these two requirements dovetail well. There's another case. You're using Phoenix channels. Phoenix channels are implemented as gen servers, so this is sort of a cross with some of these things we've just seen. Maybe you don't want to drop events. Maybe you're migrating state that's in one of your channels. Or you don't want to deal with a thundering herd of reconnections. You can turn it off, and then the client will recognize that and then try to reconnect, which, cool, it's easy for the developer, but that can present a lot of load on your system all at once. Maybe that's cool, maybe it's not. So that's why upgrades. Well, why not upgrades? Like I said, I'm not trying to sell you anything here. Turn it off and turn it back on again is a pretty well understood paradigm. We do that for everything. Humans do that when we go to sleep. That's basically turning it off, turning it back on again. So, it's valuable, it's worthwhile, it's something to consider. This does not play well with blue-green deploys. If that's how your infrastructure is set up, it can be tricky to bring up the blue box with the new state, and then, well, if you have two different boxes, then you're not really hot upgrading. So that doesn't make any sense. And the prevailing pattern for web infrastructure is really designed for stateless web servers. This is the legacy that we have after 15 years of web services, written in Ruby, even written in Java. Like the JVM, you can't really hot upgrade, and I think does need to be turned off and turned back on after so many years. And finally, something Docker. We've been hearing a lot about Docker today. Listeners of the podcast know I am not a big fan of Docker, and it can make hot upgrade. It fights with hot upgrades. It's a different paradigm. Same thing with Kubernetes. We're using Kubernetes at work. We're moving away from it for various reasons. I don't think Kubernetes is a good fit for an Elixir system. If you're writing an Elixir system that's just like stateless, web server, whatever, it could be written in any language, sure, spin it up, kill it, whatever. But when you start talking about, I want this thing to persist, I don't want it to be dropped, I don't want the bottom dropped out from under me, Kubernetes stops making sense. But, if you're not doing that, maybe not upgrades. But you're here at a talk for hot upgrades, so just give me the goods. Let's see what's going on here, right? Let's assume that you want to do this, and let's see what's involved. The good news is, you're interested, you might get them for free. Cool. I don't have to think too much about it. To understand this, we have to ask ourselves two questions. The first, are you changing any in-memory state? This includes, if you're keeping state in gen servers, as I said, including Phoenix channels, if you have state in ETS tables, or if you're changing the shape of a record, including ecto schemas, like if you're migrating a table in your database. And this is the key part, you are keeping a copy of that in memory. You're storing that somewhere in your app. If you're not storing it in your app, doesn't matter. Answer to question 1 is no. Number 2, are you altering your supervision tree? This includes changing the restart strategy of a supervisor. It includes adding or removing processes underneath your supervisor. These could be ordinary gen servers or workers, whatever. These could be other supervisors that are underneath your one supervisor. In that case, or if you're not doing any of that, then you are approved for free hot upgrades. They're just upgrades, as we're saying. Like, you don't have to think anything about it. It'll just happen. You're just replacing modules and removing other modules, and the system will do that for you, and you don't have to think about it. So this presents us with a situation where we can do very basic upgrades. And the key piece to this is that when you're doing upgrades, you have to think about the version of your system, which is specified in your application's mix.exs file. And a good thing to do is to take the number out of that file and read it from a version file, which could just be one line, keep your semver in another file. And what's nice about that is if you're writing a deploy helper script, it's very easy to read this file in, bump the version, write it back out, and then automatically run these commands below. The first, we build our upgrade, mix edeliver build upgrade with 008, and then mix edeliver deploy upgrade to production with the version that we are deploying. I didn't mention edeliver on the earlier slide of stuff you should know, but it's a wrapper around Distillery that coordinates building and deploying your app. As we can see, it makes these commands very easy. 008 is the old version. I couldn't tell if it was like the previous or current version coming from, and the one you're going to is down there at the bottom. The system doesn't have an inherent knowledge of what these numbers mean, but it has to know which version you're building an upgrade off of, so it knows how to diff where you're coming from and then what the new thing is. So numbers aren't important, but you have to keep track of them. Like, knowing that is important. So you answer no to the two questions, you run a couple of these commands, and you are good. Upgrades, not so bad. All right, well, how does this even work? The Erlang VM understands upgrade instructions natively. This is not a bolted-on thing. This is like you're running code in the VM, so it natively knows how to reload what's in it. So there's two key pieces to this. There's what's called the appup and the rellup. These are two files that are generated for you by Distillery. And then the rellup is a generated file is generated from the app up and something else that has the low-level instructions for how to actually. So I just covered a lot of this. It'll take the format of this large tuple with the version, and then the second element is a list of the upfront version, and then instructions for how do we upgrade. And then there's also an element for downgrading. You can upgrade. You can also hot downgrade in case something goes wrong. I tend not to do that very often, but it's there because when people were designing the system, they thought it through. So let's look at one of these files. There's a lot going on here. At the top is our new version, 0.1.12, and we are coming up from 0.1.1, and we will also go down to 0.1.1. These will tend to be the same. They don't have to be. And our instruction is update, and then the name of a module, Supervisor 2, and then add module, BigElixir.worker2. So here what I've done, I've changed something in my code. I've changed my supervisor file. I've added a worker process underneath it. So Distillery has intuited that we need to update the supervisor module to change the child specs, as well as add this new module, worker2. There's a few more things that go into this, which we'll look at in a second. But then the downgrade is the opposite, sort of. We still have to update supervisor 2, but we're also, this time, going to delete the worker module. That's our app-up file. What's the Rellup? The release upgrade. As I said, these are low-level instructions for performing the upgrade and downgrade. These will correspond to functions in the VM. It looks very similar. We have a version, and then a list of up from version description instructions, down to version description instructions. Going up to 0.1.6 from 0.1.5. Looks similar but different. Now we have these commands load object code. That sounds pretty low level. And then this thing called point of no return. So it understands that at some point during this upgrade, you have to keep going. Like, you can't get midway through this thing and then just pull the plug. And so it knows, okay, if I've gotten to the first thing and something fails, I can just like easily roll back. That's fine. Once I've passed the point of no return, well, you know what happens next. The next command, load, we load a new file. BigElixir3 is a new worker. And then brutal purge tells the VM what to do to any processes that are currently running the old version of the module. So we're going to come back to this Rellup file when we have a better example, and we can see how these commands correspond to actual functions in the VM. To get there, we have to get into a more complicated situation. In other words, remember our two questions. You've answered yes to one of those questions. This is where shit gets interesting. The two questions you may remember are, in the first, you're changing state that's kept in memory. The shape of a data structure, a database table, whatever. Or you're changing a supervisor. So let's look at these one at a time. You're changing process state. So we'll take the example of a gen server, which is holding state, and you want to change what's in there. The first thing we have to think about is this version module attribute. This is a reserved attribute. All modules in Erlang have versions. You typically don't specify it, but if you don't, then the VM will set it to the MD5 checksum of the module. It doesn't matter if you're not doing upgrades, like, it doesn't really matter what the version is. But if you are doing upgrades, you'll need to start setting these yourself. What you set them to doesn't matter as long as you understand what they are. I don't version my gen servers until I start upgrading them, because again, it'll litter my code and they're not really useful unless I'm using them to do these upgrades. So, step one, set version. The second piece of this.
I'm taking some RF hits on that one, so we're going to swap you out.
Oh. The second piece. Cool. Better? Is this working? No? Yes? Maybe? Right, where was I? Oh, the second piece. So first we have to set this version. And the second piece is we have to implement the code change callback in our gen servers. This is part of the gen server spec. You typically don't have to implement this because you're not changing code. But when you are, we have to write this function. And it looks like this. It takes 3 arguments, the old version, the state of your gen server, and an argument called extra, which is something that can get passed in from your release upgrade file. And this will either return the tuple OK new state, and if that happens, then your gen server state is replaced with whatever new state is, or it returns error reason, in which case the upgrade will fail. The upgrade will continue, but the process's state remains unchanged. And what we'll want to do is implement this function and pattern match on old version. What does that look like? So here's our module. So we've set our version to number 4. We are coming up from 3. Version could be Jiminy Christmas, and the old version could be Mickey Mouse. I'm pretty sure that's right. I'm pretty sure, well, you might have to use a number, but it doesn't matter what the number is. It just knows, the VM knows what your current version of a module is and what the old version is. So as long as you're keeping track of that, you're good. So here in our code change, we have been storing a temperature in state as Celsius, and we want to convert it to Fahrenheit. So we add this to our gen server, perform our calculations, return OK new state, and then the next call to our gen server will have our new Celsius, Fahrenheit temperature. And that's it. You've migrated state. Cool. How does this do this? Let's go back to our release upgrade file. So this is a little more interesting. Looks similar to before. We load our object code. We pass the point of no return. We have to suspend our worker. In other words, get it to stop running so we can operate on it. We load in the new code, the new version of the module. We have this code change up, and then we resume it. So, and then there are downgrade instructions here that I've left off. The key piece of this is this code change up instruction, which is what tells the VM to call that function in our module. There's no magic here. This is all being explicitly told to the VM what to do, and then the VM turns around and calls your module. But there's another interesting piece that's going on over here. You may notice the suspend and resume. Well, it makes sense we have to suspend a module or suspend a process in order to change the state, because if people are accessing it while I'm changing state, then you can end up in a funny situation. So we turn it off, or pause it for a second. But what does this mean? Downtime. So this is the downtime I was mentioning earlier, where if you are migrating a lot of the state of a lot of processes, like each process is only down for a small fraction of a second, but if you're storing a contentious resource in a gen server that everyone wants, and then you suspend it while you upgrade the state, everyone's still going to want it, so that can cause backups in your application. Now, if you have a contentious resource, you shouldn't be storing it in like a FIFO gen server. You should probably put it in an ETS table where it can be read concurrently. But again, things to keep in mind. So I mentioned earlier that these are low-level instructions. They still seem sort of like whatever. It seems like gibberish to me. But these are not suspend, load, code change, resume. Like, this is not out of nowhere. These are actual functions, like Erlang functions in this system module. And so we can run this in IEX and do exactly the same thing. And we can sort of flip back and forth here as we see. The first thing that happens, we compile a file. We suspend the process. We purge the old version. We load the new one. We'll change code, which triggers our code change callback. And then we resume it. Suspend, load, code change, resume. No magic. These are functions built into the virtual machine. Pretty sweet. Some other considerations. If you are changing state, you do not want to put database migrations in code change. You want to embrace multi-step deploys. You deploy an upgrade, you add a column, change your application code, go back in and clean it up later. This can seem like a lot of work if you're running a small app. If you're running a larger app with a large database, you'll probably want to be doing this anyway. But don't start thinking that you can mix these up. Database migrations go in your migrations, and then in-state or in-memory state changes go in here. So again, requires some thought to keep track of the order in which these things are happening. If you're changing the state of an ETS table, there's usually a gen server associated with that as its parent, so you'll probably want to put a code change in that, implement that code change, that then updates any state in its associated ETS table. The table itself doesn't have a way of like changing itself. Doesn't seem too bad, but there are some challenges. Developers must keep track of what they're changing and communicate it to the rest of your team. If you make a change today and it's released tomorrow, then you have to be aware that when the release is built is when these AppUp and Rellup files are generated, not when you commit your code. So you need to be aware of, am I making a change that could ripple throughout the system and affect something that I'm not aware of? Do I have to communicate to my DevOps team how these releases are going to work? I mentioned Distillery will generate AppUp and Rellup files for you, but they may not be perfect. They've been pretty good in my experience, been very, very good. But they may not be perfect, and it's not Paul's fault if you don't look at it and your system screws up on deploy. So you have to be ready to review these files and make sure they look good. If you're making lots of changes before you actually do a release, then you may have to build out code change several times. So the goal here, the trick, is to make your releases as compact as possible. The bigger they get, the longer you go without deploying, the more complicated the stuff's going to be. And you might want to retain some of these code change functions in case you do want to downgrade. I will keep like the last version. I generally don't want to downgrade more than one version. I've never had to downgrade. But if you're running stuff in production, it's nice to have that way out. Our other question, remember those two questions? I feel like we keep bouncing back and forth, but this is in my brain work, so I hope it makes sense to all of you as well. Our second situation is when we're changing a supervision tree. Suppose we're changing our restart strategy. That's handled by updating our init function. Supervisors have no code change callback. It just calls init again. If you're adding a child process or removing it, that has to be done manually. There's sort of two steps there to changing the child processes, which we'll look at in a second. But if we're changing the supervisor restart strategy, so here's our release upgrade. Here's our crucial line, code change up on the supervisor. So it's the same instruction to the VM, but when you've implemented the supervisor behavior instead of genserver, it calls init instead of code change. So we have our regular init function. You'll just rewrite this and change whatever is in strategy. Here I've changed it to rest for one. And that's it. Pretty straightforward. I don't change my restart strategies super often, but if that's what you need to do, super straightforward. But what about the case where you're changing the children? So here I want to add a new child process. And there's a couple pieces to this. Here I'm adding it to my child specs. And you might think, great, it's added to the child specs and I'm done, but you are wrong, that's not enough. So the problem here is adding it to the child spec does not start and stop children. The supervisor doesn't know how to reconcile its child specs with what is actually running. So you have to tell it to run or not run something. It's still necessary to add this here instead of just adding it, like just adding the child as supervisor, because if this supervisor dies for some reason and gets restarted, this child process is not in its spec, so it will start up all of the other children except for new child, and then we're out of luck. Child specs will be added but not deleted, so I can add many of these things. If I am removing them, then this will not work. I'll still have to change children to reflect that it's no longer there, but the supervisor will not take it out of the list it already knows. So we have to do that ourselves. There's two options for this. The first is we can edit that Rellup file directly ourselves. Remember, those are just functions, so we can write functions. And there's great resources in the Erlang manual for like what these things look like. So you can edit that file yourself. It'll get run during the upgrade. Or you can run a command in your app separately to do this. I prefer the second one because mucking around in a Rellup file is not a thing that I like to do. But your mileage may vary. Maybe it is easier because there are some trade-offs with doing it the run command in your app way. So what this looks like is a custom distillery command. This was mentioned in a talk earlier today. You basically define a function in your application, and then you expose it via a bash command. You expose it via bash command. You kind of like, part of the wiring is you write it up in rel config exs and put it one other place. But then on your server, you say bin my app run and then this thing, and then it runs your function and passes in whatever command line arguments you've given it. So here, what does that look like? We define a module myapp.treeChanger with a function addChild. Takes a supervisor and a child. Remember, these are going to be arguments coming in from the shell, so they will be strings. So the first thing we need to do is atomize them. And then we call supervisor start child. And then we're done. Not so bad. So this is adding a child. If we remove a child, it's a little more complicated, because remember, our child specs are additive but not removative. So we have to do that ourselves. So here's the remove child function for our tree changer module. Again, we take a supervisor and a child, the string name of the module. We atomize them. And the first thing we do is we terminate child. So we get the process to stop running. And then we delete child, which removes it from the child spec. So now we've covered both of our bases. Not so complicated when you see it in 2 lines of code. However, at this point, we've already deployed our application. So the developer has remembered, okay, I've deployed it. Now I have to go on the server and like run some other commands. So it is sort of challenging because it's a multi-step process. And again, the longer your releases happen away from when you've written the code, the harder it is to remember this stuff. And if you're running on several boxes, it can be challenging to go on each box and then run this command. In that case, I would edit the Rellup file directly. Realistically, you'll want to get good at editing these files. Like if you're down to do hot upgrades, you're going to want to get comfortable with these things. The good news is it's not that hard to get comfortable with them. It just takes a bit of practice. We're all smart people here. We've learned a lot of stuff before. Like, you can learn these files too. And then it's automated for you, and the stuff is free. So that's cool. And those are the two, those are the two main pieces. Like, you have these two questions. Am I changing state in memory? Am I changing my supervision tree? If you're not, then you have the upgrade for free. It's no more difficult to build than a release. Again, depending on your infrastructure, it could be complicated. But if you are changing state, the VM gives you facilities for doing this. Like, the system was built with this ability in mind so that it wouldn't have to go down. So I think, again, these hot upgrades get a bad rep, and people say, oh, well, it's not worth it. It's complicated. And maybe it's complicated. But take the time, once you see what it is, like, there's really not a lot there. And we're doing a lot of this stuff already. So it brings me to the summary. Upgrades are not scary. They just require a bit of thought. This doesn't really work with like continuous delivery where you're just tossing whatever out there and like, yeah, it'll probably work, yeah, whatever. Like, you have to really develop a release-oriented culture. You can take a page out of Josh's book and establish some processes around this. And once the process is in place, then the stuff, it happens for you. My company, we're moving towards keeping almost all of our state in memory, and we have uptime requirements. And every time we turn on our app, it thunders the herd against the database, and that's really tough. So we are going in this direction, and we're really jumping in with both feet. So this is the plan we're using. Stay tuned. I think everything will work out fine, because again, this technology is like 30 years old. You're responsible for having the correct app up and Rellup files. I have not seen one not work. So Distillery is pretty good. But the way like building a release works, it wants to generate a tarball for you, like a release of the tarball. So then unpacking that and digging these files out is a little tricky. So you'll need to engineer your process a bit so that you have access to these files. You're not going to want to write the file yourself. Let Distillery give you the framework, and then review it before it goes out. So if you're like me and you're running a stateful system, which is what these systems are designed for, then this is really your only option for changing state. And I'm a big believer in having some of these stateful systems. I think it will enable new programming paradigms, like new interesting kinds of applications in the next 5 years. So in order to support that, we need to get comfortable with these tools. We need to really like see it through to the last mile and not bail because we've gotten to the edge of the high dive and it's a long way down. It's fine, just jump. The thing is, if you're changing state in your database, you're already doing a lot of this stuff. We've internalized the idea of a database migration. We write an up, we write it down. We write data migrations in there. Oh, what happens if this thing isn't set? Okay, and like I said, a lot of us are already doing these multi-step deploys where we add a column to the database and then change our application code and then like have another migration later that removes the column. Pretty common pattern if you have large database tables. You're not going to be running an alter table on a 100 million row table in production. So this is not asking any more than that. This is just asking you to apply that knowledge somewhere else. And really, why not learn something new? Like, we're all here at this conference to learn stuff. We're learning this new programming language. Like, keep going. You know, dig into the rest of this. And it may not be worth it. It may not be what you want or need or whatever. But like, challenge yourself. Like, have some fun. Yeah, we can upgrade this stuff for free. Like, why not do that and go to some other conference and brag about the sweet things we're doing instead of being like, yeah, we could almost do it, but we're too afraid to do it. I mean, like, come on. And if it does happen and you have some fun with it or you don't, call into the podcast, let us know so we can share that experience with other people. Because not a lot of folks are doing this. Like, there's a real opportunity right now for anyone here to really be at the leading edge of like stuff people are doing with Elixir. So I would say, yeah, be brave. Like, try this out and you know, let us know how it goes. Like, we're all looking to see some of these reports. There's some further reading. So Paul, who's coming on next, has written some excellent documentation as part of the new Distillery 2.0 around app-up files, how upgrades and downgrades work, and some of the internals of these systems. The Erlang cookbook, the Erlang, I don't know what you call this thing. The Erlang documentation has a very nice app cookbook which describes what a lot of those functions that I mentioned are. Some of the tuples have different shapes, and it goes through all that stuff. So the docs there are pretty good. I recommend reading up on all of these things on a rainy afternoon. And that's it for me. Thank you.
So nobody should be afraid of upgrades now.
Nobody.
No one. All right. Questions?
Did someone come around with a mic? Okay.
I'll go over there.
Thanks for your presentation. I was really turned off earlier when I heard that in Erlang and Elixir, folks here are going the same route as with any other language. I was like, well, that's why we're doing Erlang then. When I heard about Kubernetes and Docker, and I was, yeah. So thank you so much.
You're welcome. I don't want to turn this into like a passing the ball around between like anti and pro Kubernetes, but I do think that Kubernetes like was built for a different problem. And when I say that my company is on Kubernetes, that's because we were originally a Rails app, and I think it can make a lot of sense in that environment. But you know, Elixir apps are written like as sort of microservices. Like, they stop and restart parts of themselves as needed. Like, we get a lot of the stuff that Kubernetes forces on us, only we've been doing this for 30 years. So I don't, like, again, if you're running your app as just a stateless thing, then sure, whatever, but I think you're missing out on a lot of the benefits here.
You mentioned versions a couple of times. Those
Yeah.
numbers popped up, and you also mentioned sort of quickly that you may want to write that to a separate file and interpolate that in. I was kind of wondering if you could revisit how maybe that gets referenced, either in like the command line commands you were showing versus like the actual app code, or maybe I'm eliding a few concepts and just getting confused. I don't know.
Is your question about what do we as the developers do with the module versions, or?
And is
what
that
comes into
version
play?
different than the one you're specifying, say, in like the original command line utility you're using in the beginning? Sure.
I think he's asking about application versions versus module versions.
Yeah, I think that might be.
Yes,
just
those are totally
confusing too.
different.
Okay.
your app version is an application version, and then every module internally has like its own version. And that's how the VM knows like what is the current module and what's an old module. And the VM will keep 2 copies of a module in memory, the current and the old. And so when you load in a new module version, it just promotes, it makes that one current, it makes current old, and then drops old. And that's managed entirely separately from your application version, which is used to know how am I building an upgrade? Like, what am I basing this current look of the app off of, like an old snapshot of the app? Sure, pass it around.
Yeah, so we got a whole group over here. When you mentioned like multi-nodes, sort of, but if you're running a service across multiple nodes for high availability or whatever, how does that upgrade process go? Do you usually do like one at a time? Do you try to like have all of them upgrade to the new version as quickly as possible? What's the strategy there, or the trade-offs amongst those strategies?
That's a good question. So you generally, I don't think you want everything upgrading at the same time, because then if something in your upgrade is borked, then everything goes down at once. The challenge there is if you're changing the shape of data and there's a moment where the first server thinks it looks like this and then the second hasn't caught up yet, then there's disagreement. But I think that's true of any situation where you have like some shared piece of data. So I go through nodes one at a time for the upgrade. Yeah.
Not to bring up something that has already been brought up a few times, Kubernetes, but I tend to agree with the concept that like the Kubernetes rolling upgrades and all that sort of stuff doesn't really fit, or doesn't necessarily fit. But I know that Kubernetes has a lot more just other stuff than that. I know, and I've heard a little bit about like stateful sets, like for your pets versus your cattle, and I'm wondering if anybody's looked into sort of unifying that, like being able to have in Kubernetes, but just not as a Kubernetes, one of these managed pods or a service or whatever they're called, having it as like a stateful set or whatever it is that's called. If anybody's doing any sort of work in that direction,
you'd have to ask Google.
I will ask them the next time I see them.
I don't know. I'm not a big Kubernetes expert, to be honest. Again, I know a lot of people here are fans of it, and we can fight it out later. So everyone show up to watch that.
I got a quick question. So on your upgrade function where you were deleting a child, you called, I believe it was purge and then load.
Yes.
I believe that was the order. And this may be a totally noob question because I'm fairly new to this, but when you do that, would the supervisor not automatically detect that and try to return to the desired state?
So detect what? That we purged it?
Yeah, that you purged one, right? Because if I go to and manually purge it myself, the desired state's going to the supervisor's going to notice that and restart it.
So I think purge is not what you think it is. Yes, terminate child will not restart it.
So when you terminate it, then
Wait a second. I think it happens. I think it happens in the other order.
I had the same question.
So I may have said this backwards. I don't know that I did. But we first want to, if we remove it from the child spec, then it won't get restarted because the supervisor no longer knows about it. So we just have to do it in that order, where it's removed from the child spec, and then we can turn it off. But when I tested it in this way, it did not restart. But I think that's because at this point, the module, in my example, the module backing that child had been deleted. So if it tried to restart it, there's nothing there. But I think for safety's sake, because behind the scenes, maybe it is trying to like spin around. I think so, yeah. Yeah. Does that make sense? I think so, because it's still running under the supervision tree. Yeah, that's what it knows about.
Question right here.
I had a quick question in regards to when you're doing an upgrade and you don't specify a code change for a version, there's like, I'm assuming like a no match on that code change. Is the default just to keep the current state and like keep the gen server running?
Yes, exactly. So code changes is a required callback for gen servers. We don't usually write them. There's a couple things that we don't usually write. The use gen server Elixir Behavior puts those in for free. So by default, behind the scenes is a code change that just has like an empty first argument, so it matches on whatever, and it returns the original state. So then nothing happens. Yeah. It's cool seeing the room from this angle.
Okay.
Any other questions?
Last chance. All
I'll
right,
be around
everybody.
later. Thanks a lot.